Hello there, this is Mrs. Mouton, and today we're going to talk about the area of circles. I thought it would be neat to start today's notes with a joke. So I will give you the question in the beginning and I'll end our notes with the answer. This is actually out of a book that one of my students purchased and shared with me, Math Jokes from Mathy Folks. So a shout out to Noah. Thanks, Noah. Today's joke: where do they put mathematicians who commit crimes? So I'll give you the answer to that. You have to watch the duration of the notes to figure out where they put them. So we're talking about the area of circles. Last week, or this week, depending on when you're watching this, we talked about the perimeter, which, remember, measures the distance around. Well, the area, of course, is the space on the inside. In class, we'll actually look more at hands-on activities to really delve into this formula. This notes tutorial is more about just using the formula, using the information given, plugging it into the formula to find the area for circles. You'll need the radius, so just a reminder that the radius is half of the diameter. It is a line segment that connects the center of the circle to some point on the outside of the circle. And we're going to need to use that all-important number pi, which usually is rounded to 3.14. So we talked about circumference. Here's a picture of the diameter, and just a reminder that it takes two radii, the plural form of radius, to form one diameter. And here's our formula. So pi r squared sounds like area to me. Area, or A, stands for area in our formula. Pi, usually 98% of the time, we're going to use 3.14 for pi. And r, of course, will represent our radius. I do want to point out that this is radius squared. So take a pencil and circle or highlight or underline that. That is an exponent. We're raising the radius to the second power. We are not multiplying by 2. Remember, circumference was 2 times the radius to get the diameter, and lastly multiply it by pi. That's not what we want here. Now we want the area, so we're going to have to raise that radius to the second power. So in example number 1 in your notes template, you're given a radius that is 3 centimeters long. We're going to plug the values we need into our formula. Area is equal to, and this is what we want to see when we show our work for area, 3.14 times 3 times 3. So we're not going to double 3. We're not going to multiply it by 2. We're going to square it or multiply it by itself. So take a few moments, maybe hit pause on the video so you can grab a calculator or do this math by hand. 3.14 times the radius squared, or 3 squared, is 28 and 26/100 centimeters squared. Again, just want to emphasize that now, since we're talking about a two-dimensional measure, if it was a polygon or a rectangle, we'd call it length and width, but it's certainly the measure of a two-dimensional space inside of this circle. We're going to take the measure centimeters, or the unit centimeters, and we're going to square that, showing that it is a two-dimensional measure. We are not squaring the area. The area is 28 and 26/100, period. We're just going to notate that with units, or in this case, centimeters squared. Here's another circle. The radius is 6 centimeters. To find the area for this circle, pi, or 3.14 times 6 times 6, or 3.14 times 6 squared. So maybe hit pause to actually do the math before you put the answer up there. I do not want you just recording the answers. I do want you doing the math with the video so that you get the practice, and then we'll dig deeper into this skill when I see you in class on Monday. And when you do the math, 113 and 4/100 centimeters squared. And yet another circle with a radius of 2 and 5/10 centimeters. Area is equal to pi times the radius squared. So that is 3.14 times 2 5/10 squared, or 2 5/10 multiplied by itself. Go ahead and do that in the calculator. And our answer is 19 625 centimeters squared. Number 4, our radius is 3 5/10. Same formula, we're always going to start with that formula. I'm going to encourage you to write it over and over again when you're dealing with area, because as you can see, we're starting to really use all the formulas now. So it's going to be really important that you use the right one at the right time. And our area, 38 465 centimeters squared. And here we have a circle that has a radius of 8 centimeters. We'll plug it into our formula, 3.14 times 8 squared. Go ahead and do that calculation. If you press pause while you're doing it, I'm going to go ahead and put the answer up, 296 hundredths centimeters squared. And we have a circle with a radius of 4 2/10. Plug it into our formula for area, all about area in these notes. And 55 3,896 10,000ths centimeters squared. And here are just some more examples where they're giving us the value for the radius. Go ahead and do that calculation. Perhaps press pause while you're doing it. And we get an area of 122, 65,625 hundred-thousandths centimeters squared. Well, now they're giving you the diameter. Well, if you look at the formula, you don't need the diameter. You need the radius. But we've talked about how if they give you the diameter, you can use that to find what you really need. The diameter is twice as long as the radius. Remember, the radius is this line segment connecting the center to an outside point. So if the diameter is 8, we can simply cut that diameter in half, or divide it by 2, to find the measure that we really need, which is the radius. And in this case, the radius is 4. So when we use our formula, we're not going to plug 8 into our formula because it's not our r, it's not our radius. We're going to divide the diameter in half, find the radius, requires a little extra work, and 4 is what's going to get plugged inside our handy dandy formula. So 3.14 times 4 times 4 is what we're looking at with this circle, because we cut that diameter in half to find the radius, which is what we need for area. And we get an area of 50 24 hundredths centimeters squared. Here the diameter is 16. We don't need the diameter, we need the radius, so we're going to have to cut that radius in half. And we get a radius equal to 8. Half of 16 is 8. Use our formula, 3.14 times 8 squared, and we get an area of 20 96 hundredths centimeters squared. Then we have a few more examples. Here they give you the diameter, cut it in half so you'll find the radius, which is what you need for this formula. What's half of 25? 12.5. So 3.14 times 12.5 times 12.5. Go ahead and calculate that. Perhaps press pause. It gives us 490 625 thousandths centimeters squared. And here we have a diameter of 14 2/10, but we don't need the diameter. So we've got to take it and cut it in half to find the radius. What's half of 14.2? 7.1. 3.14 times 7.1 times 7.1, 158 and 2,874 10,000ths centimeters squared. And we have another 40 and 8/10 is the diameter. We don't need the diameter, we need the radius, so we're going to cut it in half. Half of 40 and 8/10 is 20 and 4/10. We'll plug that in our formula. Go ahead and hit the pause button so you can beat me to the answer. And we get an area of 1,306 and 7,424 10,000ths centimeters squared. So, was anyone able to figure out our joke? Where do they put mathematicians who commit crimes? Any guesses? Prism. Get it? As in rectangular prism. That's clever. So they can be with other convex. Get it? Not convex. Excuse me. So thank you so much, convex. Thank you for listening to our notes. If you have any questions, bring them to class on Monday, and I look forward to seeing you then.